You can do one of two things. You can split them apart, or recognize that the numerator is secant squared. Okay? So the numerator is secant squared. The denominator is cosine squared. So if I split that apart, I get secant squared, times secant squared, which is secant to the fourth. This is 1 over cosine is secant squared.
For some reason, I always think cosine is the inverse. But
when you're multiplying inverses, they go away. When you divide them, you're adding more exponents.
I don't know. Okay, that makes sense.
That's all it was. 28 and 30 are very similar. Because what happens here, you'll notice that you're starting out with fractions and addition, and you wind up with just multiplication. So what you want to do is take both the numerator and the denominator, rewrite them in terms of sines and cosines, and try to get common denominators. You're going to create a complex fraction.
When we write them, do you always want us to use your sine and cosine?
It's one of the tricks. It's kind of helpful.
That's what I'm doing.
See, 1 over cosine.
Hey, did you figure out 55? Yes, you did. Yeah, you did.
What?
55.
Yeah, I did it in like one step. I'll show you in a minute. It was like 2 steps, sorry.
How long? When did you figure it out?
2 minutes after you left.
And then
So those two just cancel.
Nope, nothing's canceled.
Okay. There's addition.
You create common denominator for both the numerator of a complex fraction and the denominator of a complex fraction. This one already does, so this becomes 1 plus sine over cosine. This one is going to be all over sine. So it's going to be cosine times sine plus cosine. Okay? Bottom of the complex fraction. Bottom of the complex fraction. Notice how both terms in the numerator of the bottom, there's a cosine. Factor it out.
oh, it's smart.
And then this just goes right here. Now, I'm going to rewrite this as a horizontal problem, horizontal division problem. I have 1 plus sine over cosine divided by cosine times the sine plus 1 over sine.
And then you can flip, you can multiply and flip.
Now
Or flip and multiply.
Right, multiply and flip. Okay. So when you do that, you have your 1 plus sine over the cosine times the sine over the cosine times the sine plus 1.
You can cross out the sine plus one.
Sine plus 1's drop.
So the sine over cosine.
So now you have sine over cosine squared.
Which is, in other words,
Secant.
I always miss like one step. Like I get the rest of it, and then there's just one step. It's like the connecting step, and I just.
Yeah, it takes practice. These are hard. This takes a lot of time to mess around with them. Yes, sir.
So when you want to find the common denominator, do you just cross multiply?
It's not always cross multiply. Right? It's just dumb luck sometimes at how it works. Okay.
Don't work like 30 times a day.
Actually, it's just like
It's
a lot of
just
this
one
chapter.
more.
Yes, sir.
So we're testing on Friday, right? So that'll be a test, right?
Yes.
So how many goes? Well,
But as of right now, the way it says it's about 12. Okay.
So does that mean we're just having a review day tomorrow?
Yeah. Because I'm going to go over like I said earlier, what we have is to finish up some of these, and then I'm going to show you how you can use them to solve equations. So I'm going to give you some more of these and some solving equations with identities tonight.
We did 34.
I think we did one like it yesterday, but I couldn't find it in my emails, so.
We did the exact same things in the 10. Rewrite cosine squared in terms of sine squared. Cosine squared is 1 minus sine squared. So you have 1 minus sine squared minus sine squared. Done. 1 minus 2 sine squared.
Oh, yeah.
to do that. Let's use Pythagorean identity.
Okay. And what were you hitting?
I'll get you, I'll get you.
So cosine squared is equal to sine squared. Okay.
Notice.
Okay.
Yes, ma'am.
24.
What do they have in common? What
You
is,
just subtract tangent squared minus.
no, no.
Oh, you
There's
couldn't,
multiplication.
you couldn't do that? Well, like that.
That would be like canceling something off the item.
What do they have in common?
Tangent squared.
Factor it out.
Oh, you know,
That's not.
What's 1 minus sine squared?
Cosine
Cosine squared. Tangent squared is?
Sine squared over cosine squared.
Oh, so it's the same.
Okay, I did it differently, and I still got the same answer.
There's more than one way to skin a
I
cat.
subtracted tangent
I always
squared.
end up
That's
dividing.
not-
Can we do 34?
Never heard that?
I really haven't. I like to say the same. Do you need to come up with a less person's get paid? Is it?
It gets the point across.
Hey, that, I mean, if you don't remember, like, not if you put your test on this one.
This is another example of when it's important to use a trigonometric identity, Pythagorean identity. Let me finish this one first. It's another great example of when to use a trigonometric identity. Notice you have two cosines, and then thrown in the middle is the sine squared. Rewrite the sine squared in terms of cosine squared. So sine squared can be, you need to memorize those, you guys won't get those.
Plus 1.
I know.
So you get 2 cosine squared minus the quantity 1 minus cosine squared plus 1 all over cosine. Okay? Distribute your negative combined like terms in the numerator. So I have 2 cosine squared minus 1 plus a cosine squared plus a 1 all over a cosine. Okay? 2 cosine squared plus a cosine squared is how many cosine squared?
3 cosine squared.
What's negative 1 plus 1?
0. 3 cosine squared over cosine squared and cosine. 3 cosine.
Using the Pythagorean identity is how you set that one up.
Is that what they are? Just
Yep. Yep. 3 cosine. You got 3 cosine.
Oh, yeah, you got.
Which one do you want to look at? You gotta go, I told you guys, go right to left on that one, right? 16 is the oddball of the whole sheet. I guarantee, I promise you, I will never, if you put the cosine on the other side, it works really fast. On 16, I don't know if I told you, I thought I said it on your guys' way out the door.
You said it during class. Yeah, and then I forgot what you said when I got home. But I remember.
Just do it that way. I'll make sure you guys have to go left to right, because going right to left, going from a cosine to turn it into secant minus sine tangent.
I was
yeah.
like,
Good luck with that. Yeah, no, if you go this way, it's very fast. You write in terms of sines and cosine and get a common denominator. You wind up with 1 over cosine minus sine squared over cosine, which is 1 minus sine squared, which is cosine squared over cosine.
I liked that stuff.
Okay, if you go the other direction, it's so much easier. I promise I won't make you do that. Everything I set up for you guys on the test is always going to go from left to right. Oh,
1 minus sine
this is cosine squared.
Oh, because you Claire.
oh, that's the answer.
Claire,
Oh,
1 minus sine squared is 9.
And then, you were just there. fast.
Wait, can you do 18, please?
Allie, I was just gonna say that.
Yeah, you say it like you're not gonna do it.
Do this one too.
Secant is the inverse of what?
Cosine.
1 over cosecant squared is the same as?
Cosecant squared.
It's not cosecant squared.
1 over cosecant squared is cosecant sine.
Right.
Remember this?
18.
Okay.
Oh, what?
That's not.
Sine squared is what in terms of cosines?
1 minus cosine. I just always forget to do it.
Oh. Yeah, I didn't know
Wait.
Flip it.
Cosine is secant, and then you have cosine over.
Pythagorean identity to get your subtraction thrown in.
Oh, you took it apart. I was just wondering.
And then take it apart, yeah.
I'm trying to get 1 minus cosine. Oh, 1 over cosine.
Pull apart.
Yes, and then you
Okay,
have
so you have 1 over
cosine.
cosine minus.
Okay?
Yeah. What, how did you do the first part? You
I flipped it.
And then you have cosecant.
Because they were both inverses, so I just put it back to regular.
Oh, wait. We can do that?
I do 22. Hey, that's not bad. Oh, I'm sweet.
Did you get 1
What number is it? I'm good.
Can you just rewrite it in terms of cosines?
What? You should be cosine. Oh, yeah. I didn't know you could do that.
What?
I did that in your
You see that, you like,
It's like a
literally
silent
blew him
movie.
away.
Thanks for saying this.
Oh, good job.
Let's try this.
No, show us how you did it.
Oh, yeah.
Yeah, that wouldn't be good. You run cosine over 1 minus sine. Equals 1 over secant minus sine.
I couldn't believe I didn't think of this. Cosine is the same as what?
1 minus 1 over secant.
1 over secant.
1 over secant.
So I have 1 over secant times 1 minus sine. So you get 1 over distributed, you have secant minus secant sine. Secant then is,
Aww.
oh, you see where I'm going? No, don't you?
No, kind of. Sorry.
Dirty.
Why does it
Dirty.
lead? Oh my god.
Oh, that's. You're never gonna put something
like a
like that on
brain
a homework,
teaser.
are you?
It's not a Algebra 2 class, what do you expect? It's hard.
You don't like it?
Okay?
Sine over cosine. Yeah, and he's gonna put a problem like that on the test.
All right.
Because secant is 1 over
I'll show you how to use an identity to solve an equation.
Oh,
This is still kind of built in between 14.4, 14.3. There's a few of these problems in your book, not as many as I would like. This is not even really so much on a worksheet. This, using the identities to solve some of these trig equations that we've done, tends to wind up being a little bit more prevalent when you guys get into pre-calc.
oh yeah, I saw on that worksheet. It said
Yeah. A lot of this trigonometry stuff we're doing is really gearing you guys for some good success when you get to pre-calc. One of the few topics that I don't talk about is what are called half angles and double angles. There's some simple theorems and things like that that you guys will use next year. But it's still all dependent upon how you guys are with using identities. This whole identity thing doesn't really go away. And they use them a lot next year. So I thought it would be important to make sure that I give you guys some of the equations that can utilize identities without going completely, totally overboard on it. For example, if I want to solve this, within one revolution, yeah, we'll just use x and theta, it doesn't matter. Either one's fine.
No, we have to do.
Yeah, because when I'm solving these, I'm not simplifying, I'm not verifying, I'm not doing anything like that. I'm going to solve this equation, okay? When it says simplify and verify, that's when it doesn't matter if you have an x or anything in it. When it says solve, that's when you have to make sure you keep it through. Because you're looking for what angle will, that kind of thing. Now, in this case, I want you guys to realize that you've got two different trig functions. And it gets kind of difficult to solve an equation if you have two different variables, if you will. So what I want to do is I want to make it into one. A lot of times that goes with trying to use one of our Pythagorean identities, because you have squares that you can, you know how you have cosine squared plus sine squared is 1. You can move things around like tangent squared and secant, things like that. So what I want to do is create a Pythagorean identity by doing something to both sides of the equation, squaring it. Exactly. So I'm going to square both sides. Okay? Squaring the left is the same thing as saying jump squared, because it's 1 minus, for lack of better terms, just 1 minus x squared. You'd have to FOIL that out. Okay with that? So you get 1 minus 2 cosine x plus a cosine squared of x. When you FOIL it all out.
Oh, yeah.
Okay? On the other side, it's a monomial. There's no addition symbol. So you just distribute your squared term to both. So what's the square root of 3 squared?
3.
And what's sine squared? You okay with that?
Yeah.
Now, because now at this point, see how I've got a cosine squared and a sine squared? How many more, which one of those do I have more of, cosines or sines? So what should I do to the sine? Turn it into cosine. So how do you rewrite sine squared?
1 minus cosine squared.
And that's how identities are used to work with these. So this is 3 times the quantity 1 minus cosine squared. So we distribute. Are you guys okay with the left side? If I take the left side and put it in descending order?
Yeah.
So I kind of get the heebie-jeebies when it doesn't look like that.
That's me.
I'm gonna do it cosine.
Wait, so Mr. Murphy, why did you do the sine and the cosine instead of cosine?
Notice how over here you've got a cosine squared and a cosine?
So there's two
Yeah.
terms with it?
It's usually, it kind of forces you to figure out, oh, which one's going to make the most sense. And it's kind of easy to figure that out. Okay? So now we have 3 minus 3 cosine squared of x. And now we're going to set the side equal to 0 by subtracting 3 and adding 3 cosine squared. We okay with that?
Yes.
We'll move this up. All right, here's where it gets difficult. What's 1 plus 3?
4. 6.
Exactly. Now you're set up as a trinomial, and your first rule of factoring a trinomial is always to look for GCF. Also, at this point, if you want, use that U substitution. Just because it helps to factor because it's a little bit cleaner looking. Okay? I'm going to use the U sub because I think it's always cleaner to work with it. I'm going to let U equal the cosine of x.
Wait, if we use the U thing on a test, you want us to write let U equal
You're supposed to, but if you don't, it's not really the end of the world.
Like,
Okay?
you won't take points off if we don't?
I won't, but when you guys get, if you guys take the upper level, like when you get to college and stuff, they'll get kind of PO'd by you doing substitution without showing that you're doing it. Even though you are doing it, you have to designate that you're doing it. It's like doing a substitution, you have to like high five each other or something like that. I don't think they do that in volleyball or soccer, don't they? You have to like, you have to do something. It's like that idea, where you have to designate that you're going in for somebody. Yeah. You just create a whole thing with your. Have you guys seen Big Hero 6?
Yes.
No.
All right, my kids love that. Now when they fist bump, they go la 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 la.
Every time with my dad now.
You see, watch Big Hero 6 and you'll get it. So my 3-year-old goes la 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 la. Anyway, so we have 4u squared minus 2u minus 2. Take out your GCF like you guys were saying. Now, does that GCF have any bearing upon the problem at all? No. And why is that?
Because
Because
it's
it's
out.
Good. So what times what is -2? You add together to get -1. So we have 2u squared minus 2u plus u minus 1 is 0, and we are factoring by grouping again. Excuse me. So your two terms are 2u plus 1 has to equal 0, and u minus 1 has to equal 0. But u stands for? So now you're asking yourself, what angle has a cosine value of -1/2, and what angle has an inverse or what angle has a cosine value of 1?
45.
What angle has a cosine value of -1/2, and what angle has a cosine value of 1?
This takes up like half a page.
Yeah, this is a
Yeah, oh
long
my
problem.
So are you gonna put like 2 in these ones?
So in the third quadrant, cosine's negative. What's the radian value in the third quadrant with the reference angle of pi over 4? Your reference angle is pi over 4 because you're coming up, but what's the terminal side? So what other quadrant is cosine negative? Third.
So now we just do the stuff we did before.
Yeah. But remember, you're within one revolution, so you don't have to worry about tacking on ends or anything like that, all right? What's the radian value down at that point? 5 pi over 4. And then, where is cosine? 1. 0. Very good. Those are your answers. All right.
Wait, keep that.
Yes, these do take a couple of seconds to do because there's a lot of work in
So
this.
just like that before, you have to put the angle that it takes to get there.
Yeah.
So you don't put the right.
Wait, what is
Come
this?
on, come on.
What's
Wait,
the
don't get finished.
Yeah, not yet.
Not yet. Be picture number
0.
Yeah, that's a lot of space.
Try another one?
No, not yet. Not yet.
Are you kidding me?
X. I'm almost done. I swear. I would have laughed at you if you got that.
Oh, we did our questions Yeah, most of at least Mr. Charles. Yeah, it is hilarious.
All right.
I actually think it's
Are you taking that theory?
Let's do this.
There's a couple things that are on there that. Wait, is it? I mean, I'm pretty sure I got it.
Oh, yeah, sorry, there's supposed to be an X in here, sorry.
Oh.
Now it helps. Okay?
So can you just like decide if you want to use cosines or sines? Like,
Yes, exactly. In a
Yes.
problem like this, since there really isn't an extra sine or an extra cosine thrown in there, it doesn't matter which one you rewrite in terms of.
Oh, we should
Let's
get the
write
same
it in
answer no
terms
matter
of
what, right?
sine.
Correct, you should hope.
1 minus
Yeah,
sine
we did
squared
cosine
minus
last time, so
sine
it's
squared.
fine.
Okay, so you're gonna rewrite cosine in terms of sine again, is what I'm
Yeah.
hearing.
1 minus sine squared minus sine squared.
Oh.
Minus 1 minus 2 sine squared.
One is equal to 2.
And then,
One half is
I don't know.
Yeah, one half is equal to sine squared.
Right. Think of it this way, if you add this over, you get 1, it's 2 sine squared.
Well, wouldn't you get
Okay,
1
negative.
negative 2 sine squared?
No, you add.
So,
Oh, yeah, because you add the negative.
What angle has a sine value of plus or minus root 2?
30.
Try again.
Oh, 45.
1 over, and we don't need the rest.
Why don't you just yell it out?
Right, we don't have to worry about rationalizing,
Yeah, guys. Because that's the easier, because you know your sine words.
because now you're at plus minus pi over 4 is all 4 quadrants, isn't it?
Oh, yeah.
So it's all of our 45-degree angles, because it's
Yeah.
plus minus, so it's at
So we don't even need to graph.
pi over 4.
3 pi over 4, 5 pi over 4, and 7 pi over 4.
And then we have to do like a plus.
This is within 1 revolution.
Okay.
So that means at your 45-degree angles, sine squared or cosine squared minus sine squared is 0. Well, duh. What is the ordered pair at 45? Root 2 over 2, root 2 over 2. If I take root 2 over 2 and I square it, and I subtract root 2 over 2 squared, what are you going to get?
0. Wait,
Wait.
was it 0? Oh, that's cool. Oh.
Because the ordered pairs is the same. Think about it. Your ordered pair is at root 2 at pi over 4. Your ordered pair is root 2 over 2, root 2 over 2. So if you take the cosine squared minus the sine squared, it's always going to be 0. Because it's the same value of x.
Oh.
X and y are the same.
Cosine squared minus
Huh?
sine squared.
No. Root 2 over 2 squared minus root 2 over 2 squared. Think about your ordered pair. Unit circle.
It's at 45 and might be root 2 of 2
Well, what is,
and it's,
oh, there's that.
If you think about, remember, at this point here, it's root 2 over 2, root 2 over 2.
Yeah, because you go.
So if I, excuse me, if I square the cosine value, and I subtract the square of the sine value, 0.
are you clicking on a carrot?
I think so.
Why is it root 2 over 2?
So that's the ordered pair there.
Yeah.
The rationalized version.
Oh, I got you.
I was wondering. Because it's one.
That's all it is.
One over.
It's kind of hoping to see if you can catch it, how you do any work. It's the only angle that's the same sine and cosine.
Sorry.
Wait, what's the name of that?
Right. I'm just like Googling, figuring out some of the tricks and stuff. I'm not gonna yell. And if I do, you could slap me. So that's probably a bad idea.
Yeah, don't invite me to stuff. I think we need to 0, I don't think that.
That's like finding a dollar.
What's that?
That's the best way.
Well, they equal each other.
I keep finding
In order to solve these, you'll have to get 7. So in this problem here, which one do you think you're changing?
The
I was just gonna change them both.
There's nothing for tangent to turn into a secant.
secant.
But secant squared is Pythagorean identity.
Tangent squared equals secant.
So secant squared is 1 plus tangent squared minus 2 tangent equals 0. Now I have tangent squared x minus 2 tangent of x plus 1 is 0. Now, do I need to rewrite this in terms of u, or would it be okay to try to factor it how it is? All right. What if you want, that's fine. But here, all I'm going to ask you is what times what's positive 1 to add together to get negative 2? Negative 1 and negative 1. So that means it's tangent of x minus 1. Tangent of x minus 1. So what angle has a tangent value of 1?
45.
Wait, no. Wait, yeah. That's opposite of
Okay. 45. So tangent, you're telling me it's at tangent value positive 1,
first and
Yeah.
pi over 4, and
Five.
there you are. This is how we use Pythagorean identities to help set up to solve equations. It's not that tricky.
I get it. Wait. Why is it on? Oh, it's positive. Because there's no negative. And then it's negative over negative over
Wait, are we just to solve these, are we just going to be using Pythagorean identities, or do we use your
More often than not, it's Pythagorean identity. More often that's, unless the trick winds up, you have to square it to begin with, and then you drop into it.
So we should always look for Pythagorean.
When you're, if you have weird ones like this, it's usually what it's
It's just double checking. Okay. So it's sine with cosine for Pythagorean, and then it's secant with tangent, and then it's cotangent.
You could have the two up to like separate.
Yep.
And then the sine and cosine equals positive. The other one's like-
Sine, cosine squared. Yeah, sine squared, cosine squared. Correct.
The first one we did.
So easy to remember. The other one.
Where's that? Oh, I
Well,
put
it
the
just
page.
says within one revolution.
There it is. Last one of these.
That looks really scary.
Do it.
You have to write the sequence in terms of tangent.
Take a minute and try it.
I'm teaching that.
Assuming you guys rewrote secant squared as 1 plus tangent squared.
Yeah.
Now, here's the thing I hope you didn't forget.
I didn't know what to.
Distribute the negative.
Yep.
So you distributed the tangent kilogram?
Fluffy is very alive.
You have to distribute the negative 1 to both parts. If you don't do that, you'll screw it all up.
Tangent squared.
What's up?
Is it okay that I just took like negative secant squared is equivalent to negative 1? I have secant squared and then add that.
Yeah, that's okay. It's fine. So you have 2 tangent squared x minus 1 minus the tangent squared of x plus 3. Bring the other stuff over. Minus 1 plus 2 tangent of x is 0. I just moved everything to one side or up that, then I'll start combining like terms. So we have 2 tangent squared and tangent squared leaves me a tangent squared. I have a 2 regular tangent here. And then I have negative 1 plus 3 negative 1, so that's,
Plus one.
And plus 1.
so what times what is 1? We add together to get 2.
1 and 1.
Tangent of x plus 1. Tangent of x plus 1. So what angle has an inverse tangent value of negative 1?
3 pi over 4 and 7 pi over 4.
There you go. 3 pi over 4, 7 pi over 4.
That isn't
The trick is The trick is just to look at it and say, all right, which one of these is making most sense to rewrite as?
Just look at
And
it.
don't forget to distribute the flipping negative.
That's a
I did that, except for I got messed up because instead of writing 2 tangent squared, it just wrote 2 tan.
We're sorely disappointed. What I want you to do tonight is on the other side of that sheet, I want you to go through the first 8. If you want, yeah,
I'm
absolutely.
about to do the rest of these, like with the odds.
Fine, go for it. It's a great practice. That's why I know this stuff is not that easy, but the more you guys keep them in your hands to keep working on them, the better you're gonna get. Yes, ma'am.
Do you have like some extra general solutions problems that I could in those?
I'll have some more for tomorrow. How's that? I don't have them in front of me, but I do have some. I was trying to. There are, but I mean, we've kind of done them all. But I'll get some more for tomorrow. I have some. I've been quickly writing equations, so I'll write some equations with general solutions and stuff like that as well. Also, what I want you to do is back again in section 14.4. It's page 859, numbers 27, 29, 30, and 37. Those are 4 quick questions that deal with Pythagorean identity, or factoring, if you will, with the trig IDs, okay? And where is it? Yeah, it's 859, so it's 14.4, so if you want, I don't think it'll fit it on the bottom half of that page, but. All right?
And then the first year on those.
Knee hurts. Okay.
You know, stuff like what we just did with binder. It is always in class, or is it open, so you don't actually have a sheet that
Yes.
and we write down all the grades?
This stuff